Hello, welcome to UX Mix YouTube channel. Today we'll discuss about 5G technology and detail about the 5G technology. The revolution in telecommunication. First trial of 5G was done in February 22, 2018. The trial of 5G was conducted at Airtel's Network Experience Center in Manesar, Gurgaon. In the telecommunication term, 5G technology stands for fifth generation mobile technology. Unlike 3G or 4G technology, 5G technology mobile technology has changed the means to use cell phones within very high bandwidth in countries like South Korea and Japan. User never experienced ever before such a high value technology. Nowadays, mobile users have much awareness of the cell phones mobile technology. The 5G technology include all types of advanced features which makes 5G mobile technology most powerful and in huge demand in near future is ascertained. What is 5G? What is the 5G and what is the difference between 4G and 4G LTE and 5G? The next fifth generation wireless network will address the evolution beyond mobile internet to massive IoT Internet of Things for the horizon 2020. The main evolution compared with today's 4G and 4.5G LTE advance is that beyond data speed improvements, new IoT and critical communication use cases will require new types of improved performance. For example, low latency is what provides real-time interactivity of services using cloud. This is elementary key of success of self-driving cars. For example, 5G technology are aimed at meeting the requirements of mobile communications beyond 2020, supporting the unmatchable rise in mobile data consumption is an obvious objective. However, there are many challenges, including the needs to support a reproduction of devices, vast numbers of machine types, transaction, ultra low latency, deep coverage, ever more efficiency use of scarce radio spectrum, minimal energy consumption, and robust security across a wide variety of operating environments and technologies. The diversity of technical commercial requirements for 5G will require greater flexibility than ever before. There will be a need for new approaches on the number of fronts, including new wireless technology, support dense deployment of high-speed, low latency services, improved utilization of current frequency bands up to 6 Hz, and exploitation of new frequency of centimeter or millimeter wave band somewhere between 6 gigahertz and 100 gigahertz to deliver the necessary capacity of coverages. Novel technology for radio resource control, antennas, protocol, and architecture to improve spectrum utilization, reduce latency, and increase flexibility. So this is the 5G need for the 5G. Need for 5G. So need for 5G. The major difference from the user point of view between current generation and expected 5G technologies must be something else than increased maximum throughput. Other requirement includes low battery consumption, low outage probability, better coverage, and high data rates available at cell edge. Multiple concurrent data transfer paths, around 1 Gbps data rate in mobility, more secure, better conjunctive radio or SDR security, higher system level spectral efficiency, worldwide wireless web, WWW, wireless based applications that include full multimedia capability beyond 4G speeds, more applications combined with artificial intelligence. AI as human life will be surrounding by artificial sensors which could be communicating with mobile phones. So this is the main need for 5G. And the next is not harmful to human health. 5G is not harmful for human health. Cheaper traffic fees due to low infrastructure deployment costs. The 5G Core is to be the configurable multi-technology core. The core could be the convergence of new technologies such as nanotechnology, cloud computing, and conjunctive radio, and based on all IP platforms. Network requirements. An unmistakable objective for 5G network is to support the escalation in mobile data consumption, with users eager to have higher data speeds and traffic volumes expected to increase by hundreds or even thousands of times over the next 10 years. It is likely that 5G networks will have to deliver baseline data speeds of 100 mbits per second and peak speed of up to 10 gigabits per second. A further challenge for 5G network will be dramatic increase in the number of devices to be supported. Mobile networks will no longer concern primarily with person-to-person communication, as billions of new devices for remote sensing, telemetry, and control application lead to vast number of machine-to-machine and person-to-machine interaction as part of the Internet of Things (IoT). LTE advanced networks can already achieve much lower latency and previous mobile systems in principle less than 20 milliseconds, but developments in gaming, automation, and even automation and remote control, including real-time interaction over the uh, tactile internet, will require even lower delays in the region of 1 milliseconds. The 5G system must be able to respond dynamically to the requirements of specific devices and applications, applying to whichever technologies and spectrum are also suitable, and sharing resources with other networks where appropriate. This is implications for overall architectural design of 5G as well as the individual technologies and techniques used to deliver services. This is the 5G wireless technology. What is the wireless technology? 5G networks are expected to incorporate capabilities of existing wireless technology, including 4G, LTE, LTE, advanced HSPA, HASPA, and Wi-Fi, supplemented with one or more new technologies to address specific requirements between 2015 and 2020. The already substantial capabilities of LTE will be extended by deploying it in new frequency bands, applying existing and new LTE advanced enhancements, and improving its integration with Wi-Fi. However, this will not be enough on its own, and new approaches will be needed to meet some of the most challenging requirements. For example, the consumption of the large volume of data in concentrated areas will require the deployment of the unprecedented densities of base stations, and the ultra low latency needed by some of interactive application, and games will require fundamental changes to resource allocation strategies, with which could be easily achieved by the modification to LTE. Complex spectrum, as it demands as the demands of the mobile communication network increase, the acquisition and efficient use of a spectrum will become more important than ever. Satisfying the forthcoming demands will involve better use of a spectrum that is already available to mobile networks, access to additional bandwidth at similar frequencies, and the exploitation of higher frequencies in the centimeter wave and millimeter wave bands. Historically, licenses for operating mobile networks have been dedicated to individual network operators, and in many cases, they have specified with which technologies must be used in which bands. However, regulators are now critically aware of need to maximize the utilization of valuable radio resources. Spectrum neutrality and spectrum sharing are major trends that will continue as we move toward 5G. Many regulators have already relax their difficulties on how spectrum is used in particular bands, and this will continue to allow mobile network operators to utilize the latest most efficient technology in the spectrum allocations. It is most likely that 5G technologies will continue to rely on core spectrum that is reserved for the use of individual network operators to protect them against interference and enable them to achieve predictable and reliable levels of performance. However, it is also likely that this core spectrum will be supplemented that shared spectrum and unregulated spectrum to bolster capacity and throughout at particular locations and times. In many markets, mobile networks have already benefited from a digital dividend by migrating television broadcasting from analog to digital transmission to release UHF spectrum around 700 to 800 megahertz. It is likely that ongoing rationalization of broadcast services will release further spectrum in this region over the next few years. The attractive propagation characteristics of these frequencies make them ideal for delivering coverage to rural areas and achieving coverage deep inside buildings. Public mobile networks have always relied on exclusive access to licensed spectrum as a means of controlling interference levels and achieving predictable levels of performance. Licensed spectrum will continue to provide backbone of 5G networks. However, there are large blocks of licensed spectrum at attractive frequencies. For example, at 5 GHz, which mobile networks could exploit, which other Wi-Fi or LTE advanced. One possibility is that networks use licensed spectrum for robust wide area connections, for example, to carry control signaling support by dynamical access to unlicensed spectrum to bolster data transmission. Even when combined with the enhanced capabilities of LTE Advanced, this additional spectrum will not be enough to satisfying the most intense data communication requirement. For example, delivering all of the mobile data required in the dense urban area is likely to need to move into the high frequency end of the centimeter wave band, somewhere between 6 gigahertz to 30 gigahertz, or low frequency end to the millimeter wave band, somewhere between 30 gigahertz and 100 gigahertz. Challenges and opportunities. The nodal agency department telecommunication is responsible for drawing up of standard genetic requirements, interference requirements, service requirements, and specifications for telecom products, services, and networks. The most important challenge is the implementation of sophisticated and seamless services by the telecom operators. Moreover, operators and other telecom players did not give any indication on the first rollout 5G technology in the country. Currently, only BSNL and Bharti Airtel announced their 5G plans by partnering with telecom handset maker Nokia. Globally, a handful of telecom companies are targeting commercial rollout of 5G services, are keeping enterprise and retail customers in mind. Operators Verizon and AT&T and T-Mobile, however, are already working towards setting the standards by 2018. But India is still expanding its 4G networks, and it is not clear how 5G can be established in such a short span of time. The key drivers. According to some of the key drivers for 5G rollout and adoption is going to massive anticipated increased in data consumption, fast increasing digitalized life and services, growth of smart cities, and the need to have an encompassing network architecture which can utilize all available spectrum band rather than replace the existing networks. With 5G technology likely to become increasing integral and industrial businesses, and digitalization and its network function virtualization's common platform architecture has proven to be the deployment model for mobile core solutions. This will become the foundation for 5G networks in India. So that's it for 5G. And thank you for watching US Mix YouTube channel.